You know, have you ever followed a recipe? You take a bunch of simple ingredients, follow the steps, and create something amazing? Well, data science can feel super complicated, but at its heart, it's a lot like that. Today, we're going to break it all down into a simple, step-by-step recipe that anyone can understand.
I mean, seriously, just think about it. What if you had a clear, repeatable set of instructions that could take a big, confusing pile of information and turn it into a clear, actionable answer?
Well, that recipe actually exists. It's called the data science workflow. It's the structured process that the pros use every single day to take that messy cloud of raw data and transform it into powerful insights and real-world solutions. It really isn't magic, it's just a method. And to make this recipe crystal clear, we're going to cook something really specific today. We're going to use this workflow to tackle a super important problem, figuring out which high school students are at risk of failing, so that counselors can step in and help them before it's too late.
Okay, so every great chef knows that the prep work is half the battle, right? Before you even think about turning on the heat, you have to lay the foundation. It's exactly the same in data science. These first few steps are absolutely essential.
And here it is, our full 8-step recipe all laid out for you. This is our roadmap. It takes us all the way from figuring out the problem to keeping an eye on the results long after it's out in the world. We're going to walk through every single one of these steps using our student success example.
First things first, you have to know exactly what you're trying to cook. Step 1 is defining the problem. We can't just say, let's look at student grades. That's way too vague. The key is to ask a super specific, answerable question. Something like, will student X pass or fail this class? Now that is a clear yes or no question our model can actually answer. So, we have our question. Now we need our ingredients. This is step 2, collecting the data. For our student problem, what kind of info would be useful?
Well, we definitely want to gather their grades from quizzes and tests, their behavior, like attendance records, and maybe their effort, which we could measure by looking at how many assignments they've completed.
Let's be honest. Ingredients are rarely perfect when you get them. You have to wash the vegetables, trim the fat, and that's step 3, cleaning the data. Real-world data is messy. You might have one teacher who enters a grade as A, another enters it as 92, and some data might just be missing entirely. We have to standardize all of that into one consistent format our model can actually understand.
And this, right here, is why that cleaning step is so incredibly important. You've probably heard this phrase before. Garbage in, garbage out. If we feed our system messy, inconsistent, or just plain wrong data, we are going to get useless, incorrect predictions. Full stop. The quality of your final dish depends entirely on the quality of your ingredients.
Now, before we start the main cooking, any good chef is going to taste the ingredients, right? That's step 4, exploring the data. We start making charts and graphs to visualize it, just to see if we can spot any patterns with our own eyes. For example, we might plot attendance against final grades and boom! We find a powerful insight. Students with less than 80% attendance almost always fail. That's a huge clue for our model.
All right, our prep work is done, our ingredients are clean, we have a feel for the flavors. Now it is time for the main event, actually cooking with our data and building that predictive model.
Step 5 is building the model. This is where we feed all of our clean data into an algorithm. Now, this isn't some magic black box. The algorithm is just learning the rules from the patterns we already found in the data. It might learn a pretty simple rule, like the one you see here. If a student's attendance is less than 80% and they have more than 3 missing assignments, then their risk of failing is high. You would never serve a dish without tasting it first, would you? Of course not. So to test our model, we do something pretty clever. We hold back a small portion of our data, maybe 20%, and we call it the test set. Our model has never seen these particular students before, which makes it a totally fair and unbiased test of how well it can make predictions. And what are we hoping for from this big taste test? A really high score. In step 6, the evaluation, our goal is to hit a target just like this one, 95% accuracy. That means our model correctly predicted whether the students in our hidden test set would pass or fail 95% of the time. This number tells us if our recipe is a success or if we need to go back to the kitchen. Once we are confident in our recipe, it's finally time for step 7. We serve the meal. This is called deployment. The model moves out of our kitchen and into the real world. In our example, this might look like a new dashboard where a school counselor can now see a real-time risk score for every single student, helping them know exactly who needs support right now.
But hold on, the job isn't done just because the meal is on the table. In a real restaurant, you have to make sure the quality is perfect every single day. The same is true for a data science model. It needs constant attention.
And that brings us to our final and maybe most overlooked step. Number 8, monitoring. This timeline shows you exactly why this is so critical. So in year 1, our model is a huge success, 95% accurate. But then in year 2, the world changes. The school brings in a whole new grading policy. All of a sudden, the patterns our model learned are totally outdated. And look at year 3. Its accuracy is plummeted to 70%. This is what we call model drift.
And that right there brings us to the most crucial point of this whole thing. Data science is not a straight line that you just walk once and you're done. It is a continuous cycle. When you're monitoring your model and you see its performance start to drop, you often have to go all the way back to step 2 to collect new data, or step 3 to clean it differently. It's a constant loop of improvement.
So, after going through all 8 steps of our recipe, what's the one big thing you should remember from all this? Let's just boil it down.
Here's the key takeaway. Data science isn't some mystical dark art. It's a structured, repeatable process, a recipe for turning raw, messy data into a real solution that can make a huge difference. And just like any great dish, it needs constant attention to keep it great over time.
So now you have the recipe. You have the 8 steps it takes to turn big questions into real answers using data. And that really only leaves one final question to think about. What problem in your world would you solve with it?